Okay guys, here we are again in our third video for our Angry Bird project. This is the blue bird in the first edition of the Angry Bird Quadratic Project. The information we have is that Bluebird's flight is represented by the graph below. So we're going to see what we can do when we're given a graph of a quadratic relationship. So let's think first off, what do we know? What we know for sure is that we do have a vertex and an axis of symmetry based on this graph. We can see that the parabola has a maximum height right in between 10 and 15, which is 12.5. Our axis of symmetry will be where the graph folds or it reflects, and so if the path is from 0 to 26, then the axis of symmetry will be right in the middle of that. So 13 is the x value that is right in the middle of that. So the information that we now have is that we have a vertex. Okay, so we have a vertex at the point 13, 12.5. Okay, now we also know that we have the zeros because you can see right here that our graph crosses the x-axis. Our x-intercepts are at 0 and 26. So our zeros are the point 0, 0 and the point 26, 0. Okay, so let's go ahead and take that information and put it over here in our table. First off, I listed our zeros. Our vertex is in the middle, right there at 13 to 12.5. And then we're going to choose to get two additional points in just a moment. But before we can find those additional points, we first need an equation. And so with the information that we've been given, since we do have the vertex, we can definitely use vertex form for this quadratic equation. So if you remember, the vertex form of a quadratic equation is y equals a times x minus h squared plus k. And so we're going to put in the information that we do have. We do know an x and a y value for sure. We know that 0, 0 is one of the points on this graph. And we know the vertex is at 13, 12.5. So let's go ahead and go with those just to make this a little simpler than trying to put in that 26 for our x value. So we're going to put in a 0 for the y. So we're choosing this point and this one. So we have a 0 for the y. We do not know the a value. That's what we're looking for right now. And the x value, when the y value is a 0, is this first 0 right here, which is at 0. And then we're going to fill in the h value. So we have x minus h. Our h value is actually 13. If you look up here at our vertex, remember h and k is the x and the y. So we have 13. And then our k value is 12.5. So we have to do a little computation here. Whenever you do 0 minus 13, of course you get negative 13. Negative 13 squared becomes positive 169. So what we actually have here is 169a plus 12.5, and that's all equal to 0. So we will continue to solve using our steps for solving equations. This is a two-step equation. So we're going to subtract 12.5 from both sides. It comes up with a little bit of a mess over here because now we're going to have to divide by 169. But what we're going to do is we're just going to leave that as it is in a fraction form in our equation. So we just found the a value of our vertex form of an equation. So let's take that and let's go ahead and plug it back in. So the equation that we're going to be working with right here is actually negative 12.5 over 169 times, and again, go back to your vertex form. We have x minus h. Our h value is a 13. And our k value is the 12.5. So we're just going to plug that all back in. And again, this is similar to what we did in the beginning of the year when we did linear equations and we solved for the b. We're just plugging in what we do know and solving for what we do not know. Okay, so we now have our vertex form of our equation that matches this quadratic relationship right here. Okay, we can take that equation and we can now just plug in some x values to get those y values to get the output. So we're going to use an input to find an output. Okay, so I'm going to come over here to this space where I've written additional points, and this is where I'm going to do the work for that. So what we have is to get our first y value, we're going to pick an x value in between 0 and 13. Okay, I'm just going to go with 10. And so I'm going to put in everything that I do know. Have my a value. And then I'm going to plug in that 10 for my x value now so that I can get the y, or the output. So I have 10 minus 13 squared plus 12.5. And when you do all that computation carefully and you work that out, you should come up with 11, it's approximately, we're going to go with approximately 11.8. That's what you're going to get there. Okay, so whenever the x value is a 10, our output is approximately 11.8. And then if we choose a reflected point, which right here 10 is 3 below 13, so if we choose the point that is 3 above 13, the x value that is 3 above, if we choose 16, then our reflected point will have the same y value. Now if you want to test that out, you can just do this work again with a 16 instead of a 10 to be sure you get 11.8. It's a good way to check your work. And then we can take this and we can go ahead and look at our graph, and we can see right here that at approximately where 10 is, we go to 10 somewhere right about in here, and then over here is about 16. If you look up here, you can see that y value is under the 12.5 right there at about the 11.8. Okay. All right, so now we have, we already had the graph, but we just took that graph and we used it to actually find some good information here. So the maximum height in our graph is the vertex, the y value of the vertex, which is the 12.5. So 12.5 yards is the highest the bird's going to go in this path. The axis of symmetry will be the x value of the vertex, which is 13. So at 13, let's go put that as an equation. X equals 13, which means that the bird will hit its maximum height 13 feet out from where the bird began. And then the distance traveled, we can do just like we did before, and we can look right here from the base of the parabola from one side to the other. And so the base is 26 yards from 0 to 26, and so that is the distance that our bird traveled. So now you have the information for bluebird. Just be sure that you have copied that all accurately. Thank you.